is vector spaces. In vector spaces, we can discuss what is the definition of vector space and its general properties, n-dimensional vectors, addition and subtraction, multiplication of vectors, internal and external composition, null space, vector subspaces, algebra of subspaces, linear sum of subspaces, linear combination of vectors, linear span, linearly independent and dependent of vectors. Okay, let us go for definition of vector space. Now, we know capital V is the set of objects that is called set of vectors. So, on which two operations, that is addition and multiplication, defined by two scalars subject to the following 10 axioms, that is the rules given below. The axioms must hold for all vectors u, v, w in the set of vectors capital V and consider the scalars c and d. Now, first axiom, that is closure property. Sum of u and v, that is u plus v, is also belongs to set of vectors capital V. And commutative property, u plus v equal to v plus v. And associative property, u plus v plus w equal to u plus v plus w. And a zero, that is a zero vector. What is called zero vector? Additive identity exists in capital V. That is such that u plus minus v equal to 0. Next one, fifth one. So there is, for each vector capital V, there exists its negativity. That is u plus minus v equal to 0. And scalar multiplication of vector also belongs to V, such that C and U, that is CU also belongs to V. Where C is a scalar, U is vector. And distributive property, C into U plus V equal to CU plus CV. Similarly, C plus D into U equal to CU plus DU. C into DU equal to CD into U. And existence of unity. So what is the existence of unity? 1 into U equal to U. So if these following 10 axioms satisfied by set of vectors V under addition and multiplication, then capital V is known as vector space over the scalars C and E. It is generally denoted by VF, vector space over the field F. So field contains, or the field F means field contains C and D. Now let us go for what is subspace. So generally subspace we can take capital H. If H is a subset of V, then it has the following V property. That is 0 of V also in subset H. And H is closed under addition. That is, for each U and V in H, the sum U plus V also in H. Next one, H is closed under multiplication of scalars. That is, CU also in H, where U in H, C is a scalar. So if these three axioms followed by capital H in V, then capital H is called subspace of V. Next. Every subspace is a vector space. Clearly, because H is a subset of V, it follows all the properties of V. Conversely, every vector space is a subspace. Now, let us go for another property. The set consisting of only zero vector is a vector space V, is a subspace of V, that is zero subspace. So zero subspace is denoted by flower bracket of O. Okay, it contains only zero element. Similarly, let us discuss about that is a linear combination. So consider uh, maybe that is V1, V2, so on.